In grade 11, we still do linear number patterns like we did previously since grade 8, but the new part is quadratic number patterns. But before we get to that, we're just going to recap our linear number patterns. So we know it is a linear number pattern if our first difference, the first time we find the difference, is constant. So what I mean by first difference is from here to here, you are adding 3, then again adding 3, and so forth. So every term here in this number pattern differs by 3. This is called the first difference. When you want to find the equation or the general term or the general solution or whatever they want to call it, so you can find it in one of these two ways. This is a formula that when you get a formula sheet starting from the end of this year, from November onwards, this will be on your formula sheet. But you can also do it with the other way, which is kind of more inspection. So the 1 is Tn. Remember, this is a subscript, so we don't write it as so. The n has to be a little bit below. And you will find that by taking your first term, that's what A stands for, plus n minus 1, that will stay n minus 1. You're going to have to multiply out. And then the d is the constant difference. That's why this is bold here. Remember, n is the position in the sequence or the number pattern, or which term you're working with, basically. So this is basically like an x value, and Tn is like a y value. Then the other way is, you could have still called this a d, it doesn't really matter, but that's your constant difference plus c, which is some constant. One of the ways you can find it is your first term is equal to b plus c, okay? Or you can do it with inspection. Okay, this is the same one as earlier. We are adding 3 every time. So from this, our constant difference is 3. So one of the ways, if you want to do it more with inspection, is you know Tn, because they're asking for general term or nth term, is going to be 3 times n. Okay, but let's, for example, take T1. Okay, so if you substitute a 1 in there, then you get 3. Okay, but your answer is supposed to be 4. T1 is 4. So how do you get from 3 to 4? You add 1. You can test it with any of the others. Okay, 3 times 2 is 6, but you're supposed to have 7, so you plus 1 to get that 7. Okay, so from this, we can deduce it has to be 3n plus 1. That's one of the ways you could have found it. Alternatively, is with using the formula A plus n minus 1 times d, where A is your first term, which is 4, plus n minus 1 stays as it was, and the d, the constant difference, is, so it's a times 3. And you multiply out, so it's 3 gets multiplied with each term inside the bracket, so 3n minus 3, and then you just write 3n in front and add your 4 and your negative 3, which will give you plus 1. Okay, you see either way we get the same answer, so it doesn't really matter which way you do it, it's what works for you. Then finding your 20th term. N is which term it is, so there where n is, you put a 20. And also here, remember that 3n is 3 times n. You add 1, so this is 3 times 20 is 60, so it's 61. And then finding out which term in the number pattern. I say the number pattern slash sequence because they use the two interchangeably. Get more into the logistics of it next year. Anyway, which term is equal to 301? So they want you to find n, and they gave you the answer, the y value. So they gave you the Tn. So you say 301 is equal to 3n plus 1. Okay, you need to get this plus 1 to the other side so you can solve for n. So we minus 1, and then to just get n, we divide by 3. So n is going to be 100. And then if you want to, you can say therefore 300 is equal to 301. You can add it. You could stop there. The important part is that you get which term, which is term 100.